Hello everybody, this is Scott Armas. I have modified the experiment a little bit. I mounted the laser on top of the camera, which is a mobile phone, so that the perspective doesn't change as we slide the phone back and forth. So as you can see here, there's a very stable pattern in the laser light. It doesn't change at all. It's almost as though the video doesn't move. There's no movement visible. So that changes as I move it back and forth. So now I'm going to move it back. And now very slowly. You can see how the pattern changes. Now I stopped. Now moving forward again. When I stop, the pattern stops fluctuating. So what happens is that the detection probability goes to 0 every time the real component of the complex wave function goes to 0. So that violates the Born rule. The Born rule says that the probability is the square of the absolute value of the complex number that describes the wave function. But my modified rule says that it's actually twice the absolute value of the real component of the complex number. So that's why the probability is not constant as the distance changes. Distance changes, probabilities change. So what was a dimmer spot becomes a brighter spot once you change the distance. And the wavelength here is 650 nanometers. So about every 650 nanometers, the pattern changes. So even if I move it only a millimeter, it changes many over 1,000 times just over that 1 millimeter.